Hello everyone, it is my pleasure today to be presenting on behalf of our team our study titled Novel Home Monitoring of Visual Fields with the Toronto Portable Perimeter. All authors have no conflict of interest and our research program was supported by government and university agencies listed here. So visual field test is a technique to examine differential light sensitivity thresholds across the retina. Illustrated on the right here is a typical visual field report from a glaucoma patient. In such a point out, a lighter area indicates healthy retina that is sensitive to light, whereas the darker region has lost some or all sensitivity to light. The key to glaucoma management is timely detection of disease progression, and visual field test is an important part of such management to monitor the functional status of the patient's eye. In our current practice, visual field tests are usually reported every 6 months. However, studies have suggested that additional benefits may be derived from more frequent testing. One may wonder why visual fields needs to be tested repeatedly. This is because each visual field test suffers from significant statistical variability due to the fact that it relies upon patients' responses during the test. By performing the test multiple times, however, we can aggregate the results and reduce the overall uncertainty on the true underlying performance of the patient's eyes. Below, I have tabulated some estimates of how long it would take to detect a rapid minus 2.0 decibel change. This result is based on a study done by Anderson and colleagues. They found that testing every 6 months would take about 2.5 years to detect this minus 2.0 decibel per year progression. However, if patients can be tested more frequently, for example, at home using a home perimeter, then testing at even a 1-month interval at a moderate 63% compliance rate will reduce the time required to just 1.6 years. And more frequent testing could further reduce the time required to about 1 year to detect such a change. Unfortunately, current standard automated perimeters today used in clinics do not support frequent home monitoring due to its cost, size, and special setup. If patients need to perform a visual field test, they would have to visit a clinic, which would take up significant time and resources, both at the clinic and for the patient. In comparison, our group has been prototyping the Toronto Portable Perimeter, or abbreviated as the TPP. Showing the picture on the right is the whole setup used by one of our subjects. The TPP setup consists of a standard smartphone which is inserted into this VR headset, and with the TPP app we have developed, the smartphone displays the stimuli inside the headset, and patients can indicate their responses using a wireless handheld clicker. In order to make it patient-friendly, we have designed integrated voice instruction throughout the test to guide patients, and real-time post-test analysis is available right after the test is finished. Patients can wear their personal eyeglasses to correct for their vision during the test. And we have previously presented validation studies showing that our setup can perform similarly to the HFA. Given this background, we wonder if one would like to estimate a patient's performance more reliably through frequent testing, which we saw at the beginning of this presentation, may allow faster detection and progression, then can glaucoma patients perform visual field tests at home frequently in an accurate and reliable manner using a setup like our TPP? To do that, we have conducted our current study at the glaucoma clinic at the Toronto Western Hospital. We recruited patients with a history of reliable visual fields in our clinic with an MD worse than minus 4 decibel in at least one of the two eyes. Patients need to have a corrected visual acuity better than 20/40 and have basic knowledge of smartphone. Once the patient is consented, each patient was then instructed in a short session on how to use the TPP, during which they also perform a pair of visual field tests on our TPP device. Then the patients go home and perform bilateral TPP standard 24-2 visual field tests. We recommend patients to perform these tests at least twice monthly. However, patients can perform tests more frequently if they're willing to do so. Meanwhile, patients continue to be monitored with the standard care at our clinic, including testing on the HFA. To illustrate the kind of data that we obtain in this study, here is a single visual field from one of the subjects tested at the clinic, which may be done about every 6 months. In comparison, during the study, we essentially test this one visual field many times, such that at each point we obtain a detailed history of thresholds. This is illustrated in this grid on the left side. At all 54 locations of the 24-2 grid, with this patient, we obtained 76 home visual field tests performed over 1.5 years. We clearly see that many of the points produced consistent results over time, while some diseased, especially peripheral points, exhibit increased variability. And this is what we would expect. On the top right, I have zoomed in to illustrate one example location in the visual field. And we can see that frequent consistent local estimates was generated from the TPP, illustrated in the orange data points. On the bottom right shows the consistent history of the overall mean deviation from this patient, summarizing the entire visual field at each time point. So to perform analysis on these results, we'll be looking at reliable tests on the HFA and the TPP during our study period. Mean deviation, pattern standard deviation, and test duration are the variables that I'll mainly look at. First, we'll be looking at the inter-device agreement between the TPP and the HFA. This is comparing how well the TPP generates results that correlate and agree with the HFA results. Next, I'll be talking about the test-retest differences for each of the two devices. This is to quantify how reliable the visual fields are generated with each device from test to test. Now to our results. So far, we have recruited 8 patients, and the characteristics of the cohort is tabulated in this table on the right. In particular, we have recruited eyes from minus 11.5 decibels to plus 1.0 decibels so far. And these patients have performed 458 home tests on TPP, and they're continuing with the study. The average test duration we found was slightly shorter on the TPP by about 20 seconds, which is a statistically significant difference. Now I'll talk about the mean deviation agreement between the HFA and the TPP. Illustrated on the right-hand side, this figure plots the HFA MD of each eye on the x-axis and the corresponding TPP MD values on the y-axis. The MDs from the TPP are highly correlated with the HFA with a Pearson correlation coefficient of 0.9. Switching to the blend-Altman analysis of agreement between the two devices, MD, the analysis plot is again shown on the right, illustrating the difference between the MD from the two devices as a function of the overall MD. The 95% limits of agreement is delineated by the orange lines. With the current data, we did not find there's a significant difference between the two devices. Next, we will be analyzing the PSD, the pattern standard deviation. We have, again, very good correlation between the two devices with a Pearson correlation coefficient of 0.96. In terms of blend-Altman agreement analysis, we found that the PSD returned by the TPP was significantly lower by 0.7 decibel. The corresponding limits agreement is from minus 2.9 decibel to plus 1.5 decibel. So overall, the lower PSD from the TPP results is the only statistically significant difference between the two devices that we found. Moving on to test-retest repeatability, which quantify the reliability or consistency of individual devices from test to test. Note that on the HFA, we have 30 test-retest pairs at about half-year intervals. Whereas we have 277 TPP test-retest pairs for comparison, these are performed at a much shorter 2-week interval. In the bottom half of this table, I have tabulated the test-retest deviation of the HFA versus the test-retest deviation of the TPP. And the lower value in this table represents more consistent test-retest pairs. We found that the TPP tests were significantly more consistent than the HFA for both MD and PSD. And this can also be observed in the histograms that I plotted on the right-hand side. The top right histogram shows the test-retest differences of MD with HFA plotted in blue and the TPP plotted in orange. And as we can see, the orange TPP distribution has a tighter distribution, suggesting better consistency from test to test on the TPP device. And at the bottom is the same relationship in terms of PSD. Finally, I'd like to mention that the TPP test duration was also more consistent than the HFA test duration, meaning that each test takes more or less the same amount of time. So with these results, we have demonstrated so far that patients with the TPP can indeed generate reliable and accurate visual field results at home. What is the practical implication of this? Well, shown on the right is the result from one patient in terms of the mean deviation from 20 TPP tests at home versus 4 HFA tests over the same half-year period. The orange curve outlines the 95% confidence interval for estimation of the MD from the TPP results. Correspondingly, the blue line shows the estimate from 4 HFA tests over the same time period. And we can see that over time, with more and more TPP tests, we can significantly shrink the confidence interval, and this tighter confidence interval can allow more sensitive statistics to be performed, potentially allowing better progression detection. And what else can we achieve? I'd like to talk about point-wise analysis of series of visual fields. Local pointwise analysis is statistically more sensitive in detecting change in the visual field as compared to just looking at whole visual field indices like the MD or the visual field index. However, with current infrequent tests, the local pointwise approach suffers from poor specificity. This appears to be the reason why such local progression analysis has not seen wide clinical adoption outside of research. So here on the top right, I've shown visual fields from the same patient that I illustrated on the previous slide. And again, this patient's overall visual field, as we can see, did not change significantly. Neither did the MD values over the half-year period. However, at two particular local points illustrated by the purple and the blue circles, we saw statistically significant change, which is illustrated at the bottom, showing the history of the thresholds obtained on these 2 points. We can see that the thresholds from the frequent home test are shown in orange, and there are 4 blue data points from the HFA. Even though these 2 local points showed this trend of deterioration, they involve actually no neighboring points. So we can see that with frequent testing, this allows us to zoom into this very specific local level details to see if there's change on the pointwise level. And we wonder if such additional information may or may not be indicative of progression, and if such information is useful for clinical use. In conclusion, through our study so far, we have shown that using the TPP, glaucoma patients can indeed perform frequent and accurate visual field tests with similar quality to the hospital HFA test. And we believe that more robust estimation of the visual field indices and potentially local pointwise threshold analysis can allow more sensitive detection of glaucoma progression, as we discussed at the beginning of the presentation. For future work, we're looking at if testing schedule can somehow be optimized in a way that is convenient for both patients and clinicians while providing useful information through such repeated testing regime. And with that, I'd like to acknowledge the Glaucoma Society of Canada, National Science and Engineering Research Council of Canada, and the Vision Science Research Program for their support in our research studies. And for any research collaboration, we welcome you to contact us at the email listed below. Thank you, and I'd love to take the questions from you.